Hello everybody, welcome back to our video series on SolidWorks, Introduction to SolidWorks. So what we're going to be doing in this video is continuing our discussion on creating slightly more complicated shapes in SolidWorks. So we're mainly going to be focusing on creating something known as an helix, and we'll try to create a spring and then look at some of the more advanced features in SolidWorks. So we're going to look at something known as fillets and chamfers. Next we look at something called as an helix. We look at holes, equation driven curves, and then lofts. So we'll see how to do all of these in SolidWorks. So fillet, what happens is when you have any particular shape, you don't want any sharp edges. So typically you might have things either like it might cut your hand, or it might actually cause some stress concentration. So any object that you actually look around, you would actually see that edges are smoothened out. So if you recall from last class, I showed you my mug that we had, or you can pick any particular shape. So I also have kind of my pen holder over here. So if you look at this particular shape, so you notice that this particular edge, if you kind of like go really close to it, apart from the dirt, so if we kind of look really close to this particular shape, you'll notice that this is actually not a really sharp edge. There's actually kind of like a gradual slope. So this kind of maybe a little bit more obvious here. So where you notice that this is actually not like perpendicular, kind of it smoothens out here. So this is kind of like a smooth transition here as well. So anywhere you have a sharp edge, similarly on this side, so you notice that this is no longer a sharp transition. So it's kind of like a little bit of a curvature to it. So this is actually known as a fillet. So sometimes you might actually have a 45-degree cut as well. So that is known as a chamfer. So the reason they typically use fillets and chamfers is, first, it kind of is more like an aesthetics and safety issues. You don't want any sharp edges on your shape. But the other reason is you would have something known as a stress concentration and sharp edges. You will probably learn about this in other courses on engineering design and kind of like stresses and strains. But what we're going to be focusing mainly is how do you actually implement this fillet in SolidWorks. So as far as SolidWorks is concerned, you can actually do this fillet and chamfers in one of two ways. So you can either do it at a sketch level, or you can do it once you actually create your 3D geometry. So we're going to see how we'll do both of these. So what I'm going to do at this point is kind of reuse the table that I previously created. So obviously you probably realize I'm a little bit lazy, and we'll try to do actually create the fillets over here. So what I'm going to do is actually suppress this feature, or we can actually leave this, or if I want to kind of hide some of the features or kind of go back, I can say suppress, the legs go away, but I'm going to leave it in place. And then what you're going to do is actually edit the sketch over here. So now I prefer to actually look normal at the view, and then the sketch fillet is actually located here. So I'm going to click on the fillet. Now I can select this particular point, and then I'll notice that 10 millimeters is actually a little too large. So if I click here, because the radius would eliminate some of the features, I need to actually reduce the fillet over here. So I'm going to make this 2.5. And then now if I move to the mouse over here, then I can actually see the fillet over here, right? So I'm going to create the fillet for this particular point. This is fairly straightforward. This is only one edge. Here I basically have two potential ways I can create the fillet. So what I'm rather going to do is I'm going to select this line and this line. So this will actually create this fillet over here, and then I'm going to say okay, and then show you what is actually happening. Now if I kind of look through, notice that it's only the top part of the table that has the fillet. The bottom leg doesn't have the fillet. So I basically managed to select just one part of my sketch. I'm going to go back to normal to sketch view, and this point kind of like want to show you something interesting here. So this is another constraint that is automatically set up. This is known as a tangency constraint. So what that basically means is that this arc is tangential to this line. So you know what tangents means. So it's a mathematical term. So this kind of is like touching this straight line at this particular point. I wanted to do the fillet for the back side as well, so I'm going to click the fillet again, sketch fillet, click this point. So this is another way to do it. I'm going to say this, say OK, and then exit the sketch and then see how it gets rebuilt. So notice that now the whole thing is actually filleted, right? So this is Control 7, this is the normal to view, so I have one fillet over here, and I could have done the same thing for all of these other edges over here and then created my complete fillet. I'm going to show you another way to actually create this fillet, where we are actually going to use the feature menu to actually create our fillet. So you would create on the feature, so you'll click on the fillet. So this also has the option of fillet and chamfer. So chamfer is very similar to the fillet, the options are similar there as well. So I'm going to click fillet. Here I'm going to say 2.5, the previous radius. Now what I need to do is select edges to fillet. So this gives you different ways in which you would fillet. So I'm going to click on the edges. So I'm going to fillet this edge, this edge is already filleted. So I'm going to fillet this edge and then say OK. Right. So as far as the drawing itself goes, you don't see too much of a difference between this fillet and this fillet, but conceptually it's a little bit different. So because if I wanted to edit the fillet that I created on the sketch, I need to go back to the sketch and then kind of manually edit this particular diameter. If I, on the other hand, wanted to edit the fillet here, this is actually a feature on the geometry. So if I basically just right click here, edit feature, and then if I wanted to go from here to say 5 millimeters and then say OK, notice that all of the other fillets get updated. This fillet gets updated. The other advantage of using the fillet in the feature mode is that I can actually create a fillet for these lines. So the vertical lines over here. So I can create a fillet for these particular lines over here. So what I would do is do the same thing as I did before. So I'm going to click fillet. So we wanted 2.5 again. And then I'll click on this one. So now it has an option over here. So if you go down, if I say here, this is known as tangent propagation. So what is actually happening is all the lines highlighted here in yellow will get automatically filleted here like so. If I edited this and then didn't have the tangent propagation, so that is checked, then what happens is only one edge over here gets filleted. So it might be useful, most likely you'd want to fillet everything, so you would want to enable the tangent propagation. So you'd right click here and then this would hopefully be enabled by default, and then say OK, and then we're going to save our table, right? So this basically shows you how you would create a fillet and or a chamfer. So if I could have done the same thing, so I'm going to chamfer the bottom face over here. So I'm going to click on the fillet, drop down, and then click chamfer, and then here it's basically an angular distance, or I want a side distance. I'm going to select this, make it 2.5, select this particular edge, and then say OK. So now if I look at this, I'm actually creating a chamfer over here, which is basically again removing the sharp edge at that particular location. So moving on. So the next thing we're going to look at is to create helix. So helix is like a spring that you would see, so or a spiral bound that you would see. So essentially what happens is the helix not only progresses up in one direction, so it actually also rotates about the axis. So that's the reason we get the helix. So in order to create the helix, you would basically need to go to the curves and then insert a new curve and then define the diameter, number of turns, and the height of the helix. So let's do that. So Control N, new part. So I'm going to create a helix curve. So for here, I'm going to create the helix. So for the helix, it needs a reference diameter. So I'm going to click the top plane and then create a circle. So I'm going to do this, and then I'm going to dimension this to 100 millimeters. So this is going to form the basis for my helix circle. So the next thing it asks me is, let's go to the control 7 view. It basically, so this is the isometric view. So it asks me how many turns, revolutions I want. So let's maybe do 5 turns. And then this is the pitch. So I'm going to decrease the pitch. So make it say 25. So get a nice compact helix. So this is the starting angle. So if I made this 0, this will basically start at the 0 point of my helix, of my circle. I can either have it go counterclockwise, or I can have the helix rotate the other way, counterclockwise. The other thing I can also do is change the make it variable pitch, and instead of the pitch and revolution, I can also specify the height and the revolution, height and pitch, or create a spiral, which is kind of like a compressed down helix. All of these are equivalent. So basically, if you know the number, pitch, and the revolution or the height, you can calculate one from the other. So we are basically just going to do this and then say okay. So and now we have a nice looking helix. Save. This is going to be next thing we're going to do, since we have a helix, is I'm going to create a spring here. So in order to create the spring, I need a circle in this particular axis, right? So I'm going to need an spring in this particular axis. So what I'm going to do is I'm going to create a plane perpendicular to the helix. So as we recall, we're going to go reference geometry, plane, and then for the first reference, I'm going to select the helix. So it's going to be perpendicular, and then I'm going to select the second reference. I'm going to select this particular point, and then we say okay, this is my point. So I'm going to go edit, rather if you click on it and then new sketch, normal to view, and then I'm going to create a spring for my helix. So I'm going to create any which way I want, and then we're going to dimension this. So this, make it say 10 millimeters. And then what I need to do is set up a Pierce constraint here. So I'm going to select this point, my helix here, and then we're going to set up a Pierce constraint. So notice that my circle here is fully constrained. So I'm going to say okay, save it again, and then we're going to go sweep. So this is a sketch, and the path is going to be along this direction, and then this creates a nice spring. So this is my spring. When you're actually creating the sweep, you have different options. So you can basically change how the thing basically twists. So if you say keep constant normal, it'll produce a different curve. You can basically say edit, and you can basically say twist normal along the path. So now with the helix, if you basically selected a different shape, you can actually get like a square spring or a triangular spring or any other fancy spring that you need. Moving on, so the next thing we want to go is look at standard holes. And why there is a feature for actually creating holes in SolidWorks. So what actually happens is any part that you take a look around, you would actually notice that they are actually fastened together. So any like if you look at the door, the window, you always have holes in them. So because you're going to be using something known as a drill bit, you're going to have a constant hole, constant size hole, and there are only few standard holes that you can actually make. And so when you're actually trying to create the hole itself looks a little bit different. So there are basically standard ways in which the hole looks. So if I wanted to create a hole, so if I take this particular square object here, and then try to drill a hole like this, I'll notice that there is basically like a straight section and then like a conical tip. So the reason this happens is you can't really have kind of like a flat edge at the end. So what needs to happen is, because it's going to be conical, and also you might actually have slightly more fancier holes. You might actually have a hole which kind of looks like this here, right? And you might have like a pointed hole over here and so on. So all of these would be standard holes, and instead of creating a sketch for every single one of these holes, what you typically do is kind of like predefine it and or kind of like have algorithms, and SolidWorks is going to take care of all of this. So that's where our hole wizard comes in. So we're going to create like a simple hole. We'll look at different ways in which we'll create the hole. So we are going to look at a simple block on which we're going to be creating the hole. So top plane, I'm just going to create like a simple sketch. And then smart dimension this. And then say exit sketch. And then we're going to extrude this. We'll just give it some 50 millimeters and then say okay. So the hole wizard is kind of located over here. So if you click on the hole wizard, it's going to open up a dialog box over here and then show you all possible combinations of fancy looking holes that you can potentially use. So that's basically over here. So this basically shows you all possible combinations of fancy holes that you can use. So if you move your mouse over here, it will tell you what it is. So this is known as a counter bore, this is known as a counter sink, this is known as a simple hole. You could have different fancier stuff. So what you're going to do is click on the simple hole, which is the one that is currently selected, and then here you have the standard sizes that you'll basically use. So this is the ISO standard, so you'll have different standards. So if you're using imperial units, so you basically have a metric, ANSI inch, metric, and then DIN is kind of the German standard. ISO is the typical global standard that you would use. So you have other things you can do. So you can basically specify based on your drill sizes here. This is a 5 millimeter hole. Right now this is known as a blind hole, which only goes to a particular distance. So in order to create this, so I'm going to basically just use this particular shape. In order to create this hole, I need to specify where the hole is going to be located. So automatically, as soon as I say here, I need to go to the position here, and then I can either use a 3D sketch, or if I click on the plane, it will start creating a 2D sketch. So I'm going to click a few points like here, here, and here, and then I'm going to hit escape, and then it brings me the option of all the standard tools that I'm used to in sketching. So I'm basically going to maybe say make this hole a particular distance from this edge. So we'll make this 25, and then make this a particular distance from this edge. So maybe make it 15. So now this point, notice that this is black, all the other ones are blue, which basically means that this one is fully constrained. So you can actually go through the same exercise and fully constrain the other holes as well. So this creates a hole. So this is basically a 5 millimeter hole, and so on. So what I can actually do is change the hole type. So if I right click and edit feature over here, I'm going to make a threaded hole. So this is actually a little bit different in each version of SolidWorks. So since I'm using 2015, they actually have started calling it a tap straight here. So I need to click on this particular feature over here. And then what I'm going to do is figure out what type of thread I would need. So I'm going to, right now I'm an ANSI metric. So I'm going to go to ISO, which is the world standard. And then it says, okay, how is it threaded? So I can select the thread. So I'm going to go to M5, which is kind of close to the fully 5 millimeter thread. And then it asks me how I would actually want to thread this particular hole. So these are all like standard dimensions. So you might, this is basically saying that you only want to create, like mark out only the hole. This is going to be threaded. So I'm going to basically have this, and then this is known as a near side countersink, which is basically kind of like a larger opening here, which will allow for the screw to actually go in. And then I'm going to select like this, and then basically leave as is. So this is the thread, and then I'm going to say okay. So this basically creates a thread, but unfortunately you don't actually see the thread. So what we're going to do is save it first, and then I'm going to figure out how we can actually show the thread. So in order to do that, what I need to do is go to Options, Document Properties, and then I'm going to go to Detailing, and then click Shaded Cosmetic Thread. And then I'm going to say OK. So now you notice that there is kind of like a color or like an image that shows up here, which kind of simulates how the thread would actually look. So the reason SolidWorks does this is it's a lot easier to render the photo of a thread onto that particular shape than actually try to create the thread, and then as you're rotating the object, it might make the computer terribly slow. So this is actually good enough, so we'd actually be able to see what is actually happening here. So the next thing we're going to look at is known as equation driven curve. This is typically useful when you have kind of like a complicated curve that you can't easily create, but basically just create your hand shaped curve. So imagine I have an aerofoil shape like so. So if I have this particular shape, this basically has a specific equation. So if you're actually a CFD solver, or you're actually designing this, what you do is you like do mathematical optimization, and you might get like a fancy equation for this, which might be like x to the 10, y to the 7, and so on and so forth. And then if I wanted to actually create this in SolidWorks, it gets terribly difficult. Or normally if you just create points and then try to join them together with spline, it gets terribly difficult. Instead, what we're going to do is use a more efficient way, which is known as equation driven curve. So again, Control N, create a new figure here. Save it first. So I'm going to pick a plane in which I'm going to create the sketch. So I'm going to imagine I'm going to create this on the top plane. So the equation driven curve is basically located under the spline. So I'll click on here and then click on the equation driven curve. So there are two ways you can create the equation driven curve. You can basically either say y equal to x squared, so which would be an explicit equation. So I'm going to say equal to x times to the 2, maybe multiply this by 10. I need to select what the range is. So I'm going to go from 0 to say 1.5, and then say OK. And then this is my curve over here. So obviously this isn't very nice. So I'm going to click on this. Oh, actually I've opened up this either. So I'm going to make y maybe a little bit smaller. And then this is my parabola that we have. So this is useful when you have an open curve. The other one we have is known as implicit equation or a parametric equation, where you basically have x and y are each functions of a third variable called t. So if you basically said x equal to say 5 times cos of t, I need to have 2 pi t and then go 0 to 2 pi. So the other type of curve we can create is known as a parametric curve. So where basically x and y are both functions of a third variable called t. So for instance, just for the fun of it, I'm going to say x equal to 10 times cos of t, y is 5 times sine of t, and then let's say t goes from 0 to 2, and then say OK. So this is my curve that gets created. Let's delete the other one. So this is the equation driven curve. So if I make this go from 0 to 2 times pi, actually pi is not defined, so I'm going to basically go to 3.14. So this basically creates a complete ellipse. Because I've chosen 3.14, which is not a complete value of pi, so what I would need to do is like actually look up the value of pi, or I can basically just cheat and then kind of join these edges together using like a straight line like so. This will basically close my curve, and then what I can do is kind of like extrude this particular shape and then create my shape here. Right, so ideally I would want to choose a more accurate value of pi, which will actually close this curve and then give me a nice shape. The last thing we're going to look at is something known as a loft. So a loft is useful when you're going from one shape to the other. So if you remember in the last video, we were talking about kind of this, you can basically use the sweep, kind of use guide curves and go from one shape to the other. So that's only useful if they are in the same family of curves. So if you wanted to go from one ellipse like this to another ellipse or a circle, then you can basically use guide curves and kind of like try to squish the shapes together. Sometimes what will happen is you might have this shape to be completely different. So for instance, if I have this to be kind of like a rectangle like this, or kind of like maybe have a sharp edge like this, like so, like a square here, right? So and then this edge is basically a circle. Oops. This edge is basically an ellipse or a circle. I want to go from an ellipse or a circle to a square here. So in that case, what I would end up using is known as a loft. So the loft, again, Control N, new part. So the loft basically would use two sketches. So one for the bottom sketch and one for the top sketch. So for that, we'll create one curve on the top sketch, and then we need to create another plane higher up, which is going to house my top sketch. So let's do insert reference geometry plane, and then I'm going to basically say the top plane, I'm going to offset it by 100 millimeters, and then it's going to be parallel at a particular distance. So this is parallel at 100 millimeters, and then everything else is fixed. So I'm going to say OK. So I'm going to select this, and then I'm going to create a new sketch. So on the bottom one, we're going to create an ellipse. I'm going to center my ellipse like so. So my ellipse isn't fully defined as yet, so I'm going to basically dimension it. This, let's make it 50, and then let's make the other one to be, say, 100. So my ellipse should have been fully defined. Actually, the orientation of my ellipse isn't defined, so what I'm going to do is click this line, this point. Now I have a line, and then I'm going to make this something called as a construction geometry, so that it doesn't interfere with the rest of the drawing. And then I'm going to say OK, save. Now on the top plane, what I'm going to do is create another sketch, and then let's create a rectangle like so, and then I'll make it into a square. So select all of these and then make them equal, and then I can just dimension one particular value. We can make this a 25 millimeters, and then now I have to define how far this line is to some reference here. So I'm going to basically select this point, this, make it 15, and then we're going to select this point and this line and this point, and then we're going to make it, say, 6 millimeters, and then exit sketch and then save. So go to our isometric view again, and then what I'm going to do is create loft. For the loft, I'm going to select the first curve here, the second curve here, and then it'll kind of give you a preview here. What I can also do is kind of create similar to the way I created the swept curve. I can actually create guide curves to, if I particularly wanted to make the shape change more drastically, so you can create guide curves. So I actually encourage you to try to fiddle around with this and then try to see if you're able to use the guide curves and then modify this by yourself. So this basically concludes our video on slightly more advanced topics on creating solids. So thank you for watching the video. Bye.